Hi, this is Dr. Xu teaching design of experiment for engineering research. There is a claim saying that if you spin a quarter coin, you have a lower chance of getting head. As we know, the probability of getting heads or tail is 50%, but the claim said we have lower than 50% of chance of getting heads if we spin the quarter coin. I would like to do an experiment to test the claim. Here I have a quarter coin. I have marked number 1 on the head side of the coin. If we end up with head up, I will give the result of 1. If we end up with the tail up, the score is 0. So head equals to a score of 1, tail equals to a score of 0. We will do a hypothesis testing. The first step is to form the hypothesis. The null hypothesis is we just assume spinning the quarter coin, we get 50 times of head, 50 times of tails. So the null hypothesis H0 is mu equals to 0.5 because the average should be 0.5 if we do these experiments again and again. The alternative hypothesis HA is mu less than 0.5 because if we have a less chance of getting tail, the result is going to be less than 0.5. So this is step 1. Step 2 is to select the level of significance. So we use the normal value of 0.05. Alpha equals to 0.05. Then we can start doing the experiment. I will spin it for 10 times. Each experiment we call it a run. So we have a run number and we have a result.
Run number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.
Okay, let's do the experiment. As you can see,
for experiment run number 1, we got tail, so 0. Number 2, tail as well. And tail, head, tail, 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 head, head.
the next step is we calculate the t-value. So t equals to y bar minus mu divided by sigma y bar. And this equals to y bar is the sample average. So we have got 3 ones in 10 samples. So 3 divided by 10 equals to 0.3. 0.3 minus mu here, 0.5. This is assumed that the sample average distribution is centered at mu, 0.5. Divided by sigma y bar is the population standard deviation sigma divided by square root of sample size, 10. We don't know the population standard deviation. We can estimate using the sample standard deviation. So the sample standard deviation, so this can be estimated by the sample standard deviation that equals to square root of sum of I minus y bar square divided by n minus 1. So now we can calculate this s and substitute 2 here. Now let's calculate the S first. So S equals to the first value 0 minus the average 0.3 square plus second value 0 minus 0.3 square.
And the third value, minus 0.3 squared. The fourth value, 1 minus 0.3 squared. The fifth value, 0 minus 0.3 squared. The sixth value, 0 minus 0.3 squared. And seventh value, 0 minus 0.3 squared. The eighth value, 0 minus 0.3 squared. The ninth value, 1 minus 0.3 squared. And the last value, 1 minus 0.3 squared.
This whole part divided by sample size minus 1. That's 10 minus 1. If we do the calculation, it equals to square root of 2.1 divided by 9. And the ending result is 0.483. Therefore, in this equation, we substitute 0.483 to here. This equals to negative 0.2 divided by 0.483 divided by square root of 10. That equals to negative 1.31. So t-value is negative 1.31. The next step is we find the p-value corresponding to this t-value. Using the Excel spreadsheet, we can put the formula in one cell as equals to t dist. The first parameter is the positive t-value, 1.31. The second parameter is the degree of freedom. That's 10 minus 1, that's 9. And the last parameter is two-sided or one-sided. We are doing a one-sided hypothesis testing, so 1. And the result is 0.11. So p equals to 0.11. And now we compare this value to the predetermined level of significance 0.05. We find that p is larger than 0.05. Therefore, we fail to reject the null hypothesis. There is insignificant evidence to support the claim that if we spin the quarter coin, we have a large chance of getting tails. In this example, as you can see, out of the 10 spinning coin experiments, although we have got 7 tails and only 3 heads, but the result doesn't support the claim that we have a large chance of getting tails. All right, this is Dr. Xu. Thank you very much for watching. I will see you in the next video.